Graph the given function by starting with the graph of y equals x squared and using transformations, such as shifting, compressing, stretching, and/or reflecting. So we're given the function f of x equals x squared plus 4x plus 2. So we can see that this is in our ABC form, ax squared plus bx plus c. But if we want to graph using transformations, the HK form, so the f of x equals a times x minus h squared plus k, this form lets us more easily view the transformations from the equation, and I'll show you what I mean. So since we're in the ABC form, we're going to have to complete the square so that we have these parentheses squared over here. We're going to complete the square and get this into the HK form. So I have my f of x equals x squared plus 4x plus 2. Okay, so we're going to subtract 2 from both sides. We're going to move the constant over. So we have f of x minus 2 equals x squared plus 4x. And then we're going to take half of the b term, half of 4, which is 2, and square it, which would give us back to 4. So we're adding 2 squared, half of the b term squared. And so we have to do that to both sides. So then over on the left, we have f of x minus 2 plus 4. And on the right, we have x squared plus 4x plus 4. So we can combine our like terms on the left side. So that gives us f of x plus 2. Now, on the right, we now have a perfect square, and this will factor into x plus 2 quantity squared. So then our last step to get it into our HK form, we just have to take this constant back over so we have the f of x isolated. So we'll subtract that 2 from both sides. So then we're left with f of x equals x plus 2 quantity squared minus 2. Now, once it's in this form, we can more easily view our transformations. So we know that our parent function is our plane x squared. So we can look inside the grouping symbol, and we can see that we're adding inside the grouping symbol. So that means we're going to have a horizontal shift. And remember, horizontal stuff's backwards. So we're, instead of going to the right 2, we're going to actually go left 2. And another way of looking at it, if we look at our HK, our H value would actually be a negative 2, which makes sense that we'd shift that parent function left 2 units. Then if we look outside the grouping symbol, we're subtracting 2, so we know that's going to be a vertical shift down 2 units. And again, if you look at the HK of this function, we know our h is the negative 2, which is why we're shifting left 2, and our k in this case is a negative 2, and that's that vertical shift down 2. So you can see the correlation between the hk and when we're actually viewing that as transformations shifting left and right and up and down. Okay, so those are our 2 transformations. So in order to shift our function left 2 units, we know we're going to take the x values of our parent function and we're going to subtract 2. So subtract 2 from our x values. So from here, this is just a transformations problem like we did in the previous section. And then to shift down 2, we're going to subtract 2 from the y values of our parent function. Okay, so remember the correspondence, remember the table that we need to use to organize these points. So we're going to start with 3 key points on our parent function. So easy key points on a x squared function, 0, 0, 1, 1, negative 1, 1. And then we want our new function, x plus 2 quantity squared minus 2. So in order to shift these key points left 2, I'm going to subtract 2 from all these x values. So now I'm going to have a negative 2 for this x, and a negative 1 for this x, and a negative 3 for this x. Then I'm going to shift down 2, so I'm going to subtract 2 from all my y values. So this y value becomes negative 2. Our second y value becomes negative 1. And our third y value becomes negative 1 as well. So we'll go over onto our graph grid here, and we only have to graph the new function. We don't have to graph the parent function on the same axes unless it says to, and it doesn't say that here. So we'll graph the point negative 2, negative 2, negative 1, negative 1, and negative 3, negative 1. So we can see the shape here. Connect this with our parabola, the U shape. And then if we wanted to be more accurate here, it's a good idea to find our y-intercept. So we know to find a y-intercept, we just put in an x value of 0. So if I plugged into that original function, f of 0, and I did 0 squared plus 4 times 0 plus 2, I'd get 2. So I know that I can get this a little more accurate here, 0, 2. And then from symmetry, I can get another point even. So if I sketch my axis of symmetry through our vertex, so we knew the vertex was negative 2, negative 2. So I know the equation of the axis of symmetry would be x equals negative 2. So if you look at your axis of symmetry, from the axis, when the y value is 2, if I count 2 to the right, I get to this point. So that means if I count 2 to the left, I'll have a corresponding point. So I can make this even more accurate here. So then I'll have the point negative 4, 2. So we can have this just a little more accurate. And then don't forget to label all these points that you plotted here. So we had negative 1, negative 1. And here we had negative 3, negative 1. So once you get this ABC form of the parabola into the HK form, so we do this by completing the square, once we have it in this form, we just use our transformations that we learned from the previous section.